In today's video, let's go over the elimination method. Your learning target for today is to solve for two variables in a system of equations using the elimination method. So as an introduction, you have previously learned the equal values method and the substitution method for solving systems of equations, but are these methods the best to use for all types of systems? Today, you're going to develop a new time-saving method for solving systems of linear equations when both equations are in standard form. So here I've written out the steps to solving a system using elimination. So the first thing is you want to arrange the like variables in columns. This means if I have a plus b is equal to 5, and let's say b plus a equal to 8, those are not arranged in columns by like variables. So the a and b are on top of each other, the b and a are on top of each other, and we want them to be alike. So that means you would just make sure that your a's are above each other in columns and your b's are above each other in columns, okay? Second step is to pick a variable such as x or y and make the two equations opposites using multiplication. Third, you're going to want to add the equations together, eliminating a variable, and then you want to solve for the remaining variable. Lastly, you're going to want to substitute the answer into one of the original equations and solve for the other variable. So for instance, if you solve for x first, you're then going to plug that into one of the original equations and solve for y. And then last, you always want to check your solutions if you have the time to ensure that you did not make any mistakes. So let's go ahead and start. So here is a system of equations that we want to solve for using elimination. So the first step is put the like variables into columns, and that's already done for us. And just to be sure, that's what I mean. The x is above the x, the y is above the y, and the constants are above each other as well. So now I'm going to move on to the second step, which is create one of them to have an opposite, so that way when you add them, they eliminate. We already have two opposites here. See how 4 and -4 are opposites? That's what we mean by opposites. What's the opposite of 2? -2. The opposite of -5 is 5. Okay, so that's what I mean by opposites. Because they're already in opposites, I can move on to the third step I outlined, which is add the two together. And you're going to add by columns. So 4x plus a -4x gives us 0x. We've eliminated the variable x. 2y plus 3y is 5y. 2 plus 13 is 15. You then want to solve for y, so you divide both sides by 5, and you get y is equal to 3. So you solve for one of the variables. And actually I have all the steps here. The 4's eliminate. We are left with y is equal to 3. So the last step was, now that you know the variable y is equal to 3, you're going to want to plug that in to any of these two equations and solve for the other variable. It looks like I chose this one. So I used that equation. I plugged in my y equals 3 right here. And then I just solved going down, right? So 2 times 3 is 6. I'm going to subtract 6 from both sides to get 4x is equal to -4. I'm then going to divide both sides by 4 to get x is equal to -1. And that is what your final answer is, -1, 3. And the reason it is a point is because on a graph, these two equations, this is probably not what they look like, but let's pretend these are the equations graphed. This is your point of intersection, that's your solution right there. Where they cross is your solution represented graphically. So this tells me, let's see if it's at -1, 3, let's make this up, -1, 3. Okay, maybe it looks something like that. Oops, I did not go through the dot, there we go. That would be your solution. Okay, so that's using elimination. Let's go ahead and try another example. Here we've got 2x minus 5y is equal to 2 and -3 plus 5y is equal to 2. First step, make sure that they are in columns, x's, y's, constants. We're good here. Next step, make sure there's an opposite. Well, 2 and -3 are not opposites, but -5 and 5 are opposites, right? So we don't have to do anything there either, which means we can just go ahead and add the two columns, right? So -5 plus 5 gives us 0. That's why there's a huge X through it. And we're left with 2 plus a -3. Here, let me do my little plus sign here. 2 plus -3 is -1x. -5 plus 5 is 0. That's why it crosses out. And then 2 plus 2 is 4. Then I want to get the x by itself. So that's why I divided both sides by -1. -1 divided by -1 reduces to just 1. That's why you have a 1x. And 4 divided by -1 is -4. What do we do with that information? We are going to plug it into one of these two equations. It does not matter which equation you choose. Pick the one that is more efficient to use. So it looks like I chose the first one. I have a blank here, right? Because x is equal to -4, which I got down here. Once I plug that in, 2 times -4 is -8. The rest stays the same. It looks like I then added 8 to both sides to get the variable y by itself. And I'm left with -5y. Let me do a little -5y. 2 plus 8 is 10. Since it's -5 times y, I'm going to do the opposite. I'm going to undo it by dividing both sides by -5. And that gives me my y is equal to -2. And that is my answer. And again, graphically, it looks like -4, -2. That, again, I'm totally making these up. It could look something like this and like this. Well, it's not going to look like that. That's a vertical line. But yeah, that's what it might look like. The answers would be right there. -4, -2. So far, your variables have been in columns and you've already been given opposites. But what happens when you're not given either, or when you're not giving one of them? So in this one, they are in columns. Perfect, beautiful. But you do not have opposites here. You have -7, -3. And then you do have two like terms, 5x and 5x. But if you were to add them, you're going to get 10x. -7 plus -3 is -10x is equal to 10. Nothing, oops, sorry, y. No variable was eliminated, right? So that's why we have to create an opposite. And we can do that by multiplying one of these equations by -1. How do we turn this to be opposite to 5? By multiplying it by -1. So that's what I am going to do. So first, like I said, arrange the variables into columns. Done. Make opposites by multiplying one of the equations by -1. And it looks like I multiplied this one by -1. And by distributing it, I get the -5x. -7 times -1 is +7. -1 times 9 is -9. Okay. Then I want to add and solve for the variable. So once I add these cancel out, right? -5x plus 5x gives me 0x. So I'm left with 7 plus -3 is 4. -9 plus 1 is -8. I then want to divide both sides by the 4 to get y by itself, and -8 divided by 4 is -2. Then we are going to substitute into any of the original equations. It looks like I chose the first equation. I substituted my y equals -2 right here. And then I just solved like we know how to do, right? So -7 times -2 is +14. I want to subtract the negative or the +14 over to start getting x by itself. And then to isolate the x completely, I'm going to divide both sides by 5. -5 divided by 5 gives me -1. So my final answer is -1, comma, -2. So in this one, we had to make opposites by multiplying one of the equations by -1. This one. So first is, our system is 2x plus 3y is equal to 12, -4x plus 5y is equal to -2. So first we're going to arrange the variables into columns. Done. Then we need to multiply one of these equations in order to make opposites. Think about which one of these is easier to make opposites. We've got 2 and -4. Can you multiply one of those by something to make the opposite of the other? You also have 3y and 5. Can you multiply one or both equations by something to get opposites? The answer is yes to both, but which one will be simpler, quicker, more efficient? This one, because you only have to multiply one of the equations by something to make an opposite. Here, you would have to multiply both equations by something to make opposites. If we were going to change both of these equations, what would we multiply this one by? 5. And we would multiply this one by 3. They're both 15, except we need opposites, right? So maybe, I don't know, maybe multiply this one by -3 to make sure it's 15 and -15. Or you can multiply this one by -5 to make sure it's -15 plus 15, and they would eliminate. But instead of changing both equations, let's just change one. That's a lot simpler. Okay, so I think I did it automatically. I'm going to make opposites by multiplying one of the equations by 2. And which one am I going to multiply by 2? The first one, right? So the second one is -4. I want to make 2 be the opposite of -4, which is +4. So that's why I multiply this whole thing by 2. And then I distribute. 2 times 2x is 4x. 2 times 3y is 6y. 2 times 12 is 24. And common mistakes students make is they forget to distribute it to the 12 as well, or to the constant, okay? So do not forget that. And then now that I have two opposites, I'm going to add them together. 4 plus -4 gives us the 0. That's why they're crossed out. 6y plus 5y is 11y. 24 minus 2 or plus -2 is 22. And then to isolate the y, I'm going to divide both sides by 11. 11 divided by 11 reduces to 1. And 22 divided by 11 is 2. So I solved for one variable. I'm now going to solve for the other variable. I'm going to substitute y is equal to 2 into any one of these original equations. I'm going to guess I chose the first one, yep. So it looks like I substituted y is equal to 2 for y here into the first equation. 3 times 2 is 6. And then I did the rest of this in order to get x is equal to 3. So your final answer is 3, 2. That means that the solution graphically is where both of the lines intersect, the point of intersection. So now we have gone through examples where you are changing no equations because They were already in opposites, which was nice. Let's see, like here. In one of these, you had to multiply one of the equations by a variable in order to make opposites. And sometimes you might have to change both equations in order to make opposites and solve for the variables. Thank you.